This great XKCD comic came out a few weeks ago at the time of this recording about the 3 types of unsolved math problem. So this is the type of thing you might see listed on for the Millennium Prize or for Fields Medals or something like that. There's the weirdly abstract one where I know what each of those symbols means individually. I'm not sure what they mean together. There's weirdly concrete, which is what this video is about, so I'll come back to that in a second. And then there's the cursed one, where the answer is it is what it is. The weirdly concrete problem that Randall has posed here is if I walk randomly on a grid, never visiting any square twice, placing a marble every n steps, on average, how many marbles will be in the longest line after n by k steps? Somehow the answer is important in like 3 unrelated fields. This is one of the reasons we love math, too. That last line there is one of the reasons we love math, because it's amazing the number of times and all the weird places that the same math problem will show up just because they're based on similar principles or similar assumptions. And so you might have a physicist, a biologist, and a psychologist all working on the same problem because it just happens to formulate in the math the exact same way, which I've always thought is kind of cool. But what's really neat, I think I found this on Reddit, where someone has coded up this problem in a Jupyter notebook. So this is by Badly Drawn Wizards. I want to make sure I give the credit there. So I've got the link to their original GitHub repository there. It's based on the weirdly concrete problem from the XKCD comic we just looked at. Hold on, is XKCD actually in the 2500s for comics now? Oh my goodness. I've been reading XKCD a long time, I guess. So what I thought we could do in this video is just take a look at what this code does, what kind of information it gives, and maybe try to suss out how it works, at least as far as we can. So let me just make an example run here. I'm going to use the plot main function here, which is the tool to help you visualize what's going on. And then there's the stat main tool to help you actually do the statistics. So again, each of these graphs is what we call a random walk. I've done a few videos on random walks. I'll include a link to those below the like button. And what we find here is this random walk is literally a matter of every time you take a step, you then randomly determine what direction you're going to go. So for example, let's suppose we start here and we randomly decide to go north. Well, then we need a random decision between left, up, and right. But per Randall's specification in the problem, we can't go south, right? Because we cannot revisit the same point. So we randomly choose left, we randomly choose left again, randomly choose left again, randomly choose up, randomly choose left, randomly choose up, etc., right? So it makes this fun little, like, almost subway looking map thing until you end up over here, right? And so there's some special number of steps we're going to pick. So the total number of steps is n times k, right? And the other thing is we're placing a marble every n steps. So n right now is set to 2, so that's the spacing. So let's maybe say this is this is n, this is your spacing. And so every 2 steps we're going to place a marble, right? So we go, so the odd number steps don't get a marble, the even number steps do get a marble. So no marble, marble, no marble, marble, no marble, marble, etc. And the dots are going to be the marbles. And so what you get is a random walk each time, right? The idea of a random walk is it's not going to repeat because you're not quite flipping a coin in this case because you've got at most 3 options. Sometimes you've only got 2 options. So like in this step, I can't go south because I've already been there. I could go north. I could go west. And so we randomly choose west. You could, of course, end up in a position where you don't have where you've only got one place that you can go. I'm trying to see if there's an example of that here. Okay, it doesn't look like any of these give an example of where you've only got one choice of where to go, unless I'm misreading some of them. So then at the end of the random walk, it evaluates what's the longest line across this entire set of points, right? So this line going from here to here is a pretty big gap, but it's not as big as, say, this gap. not as big as, say, this gap. And it just identifies where is the biggest jump from one point on this random walk to another point on the random walk. So red, there's some sort of optimization it's going through where it's trying to figure out what the longest line is across the random walk. And then we can count the number of marbles that lie on that line. So for example, here I'd have, I don't know if that counts or it has to go through the exact center, but let's say that counts as 1, 2 there. It looks like Randall is illustrating the center there. So it might only count if it goes through the center, although that's not guaranteed to even pass through any centers necessarily. Well, anyway, point being, Randall's diagram here is a little bit different because he's moving between centers of the squares, and this code is moving to the corners. It's just a question of how you shift it, right? You could shift the grid underneath it. But then the other thing we can do is use the stat main function. This is going to run 10 samples and just going to return us the numbers. And so we end up with not very many. We end up with sample 1 has 1 marble on the maximal measure line, 2, 0, 1, 1, 0, 1, 1. We end up with 4 on that last one, which certainly looks like a lot here. Okay, so K, the number of marbles there, okay, that is the number of marbles, so that is going to be K there. Okay, right, because N times K is going to be the number of steps. So N times K equals total number of steps. Okay, right, so you are dropping a marble every N times, so if you drop K marbles, then you've taken N times K steps. Okay, now I understand how that's formulated. Okay, got it. So what I thought we could do would be take a look at this and get an idea of how this thing works. So let's suppose we go with the plot main. Let's start with plot main. So this is one of these codes that I aspire to write like, because if you look over it, everything the code does is defined in functions. And some of the functions are decently long, so like defining the plot, that's going to take a few lines. But some of these functions literally are just 1 line long. They just return something. So it's a single calculation, but rather than put that calculation over and over again, the author has chosen to define it as a function. Like I said, I aspire to write clean code like that. I don't always get around to putting everything in separate functions like that. But let's give this a try. So what we're going to do is start with plot underscore main, and let's just trace this however far we can to understand what it's doing. So let's go find plot underscore main. Here is plot main, and basically we're going to make a loop, right? Because we're doing a certain number of samples. So for I in range number of samples, that's just the number of graphs we're going to generate, and we specified that farther down. We're getting a set of numbers here, a set of values that is determined by I've lost my marbles. Nice hook reference there. And then we go to the plot walk. Okay, so let's go find I've lost my marbles. I think plot walk is going to be pretty straightforward to look through. I'm going to guess that that's just creating the graph. So that's just going through some, it looks like it's using matplotlib there, which is the standard one you use in Python. So let's go find I've lost my marbles. Here we go, I've lost my marbles, and we have K and N, right? So this is the thing that solves the problem, right? The matplotlib stuff, the plot walk is just creating the visualization. This is the thing that does the actual computation for us. So we got a few things here. We got a dimer, marbles, convex hull, longest line, and meeting marbles. Okay, I have an idea of what some of those are going to mean. Let's try dimer first. All right, what does dimer do? If n is less than or equal to 3, return a myopic walk. Else, while true, w1 equals dimer, w2 equals dimer, w equals catwalk. If saw w, return w. Okay, so what is that doing? Well, it's a recursive function because it's going to keep going down until we get down to n of 2, 1, or 0, right? And because it keeps calling itself here, so this thing is recursive because it keeps calling dimer, 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 etc. I have never seen a double slash in Python, so why don't we look up double slash in Python. The double forward slash in Python is known as the integer division operator. It will return the left divided by the right, only keep the whole number. Okay, so it's int of one number divided by another. Okay, that's a handy shortcut. I'm going to try to remember that next time I need integer division. So it's doing W1 equals dimer n slash slash 2, W2 equals dimer n minus n slash slash 2. Okay, so you're taking this in, you're basically splitting it in half, I suppose. That's interesting. Okay, so we've got W equals catwalk, so now I need to go up to catwalk. And this is where we're returning. This is one of these single line ones. It's always so nice and compact. We take W1 and we do an add function. Is that a built-in function or is that a thing we have here? Do they define add? Okay, they do define add here. Okay, so they return a tuple. They're using a map and lambda, which is the thing I should probably learn how to use. And then let's go down here. Okay, for P in W2. Okay, so it's looping over. It's adding that stuff together. And if it saw W, then return W. Okay, so what does saw do? Return length of W equals length of the set of W. Okay. That's interesting. Okay, cool. And otherwise, so once it gets down all the way to that, it's going to return a myopic walk. All right, I know what myopic means in general. That's like where you, myopia. Well, myopic, what does myopic mean? Okay, myopia is nearsighted. Okay. So W equals 0, 0, so this is the thing it's trying to get to. Okay, so it's all a bunch of embedded lambda stuff there. And then we're going to w.append choice of dirs. Okay, so choice there is, it's imported from the random function. I know that much. So it's probably random choice among a set, I think. Random.choice. The choice method returns a randomly selected element. Okay, so this is where we are trying to do a random walk but not return, because choice of directions. Okay, so this is getting us what directions are available, right? So we have directions are going to be up, left, right, and down, but we are eliminating the choices that are not available to us so that we don't have any repeats. Else raise rejection. Okay, so that's probably giving us the option of saying, wait a minute, I ended up in a dead end. Because I think it's possible to end up in a dead end there, unless there's some weird proof about random walks I'm not aware of. I feel like that should be possible to end up in a dead end. Okay, cool. So we have rejection there. It just gives us a pass there. So we return W. Okay, so myopic walk is, okay. So they're using the term myopic walk to refer to random walk, never repeat. I wonder if that's a technical term. Myopic walk. Myopic self-avoiding walk. It is, in fact, a technical term. Okay, that is cool. That's really cool. Okay, where did we leave off? Okay, so dimer is the thing that makes the walk. Then we're ready to go drop some marbles. So def marbles in W, return W. All right, what does the double colon mean in a Python array? Python array, double colon. Is that just when subscript and sequences? Okay. Oh, okay. Colon 3 means every 3. Oh, okay. Slice multidimensional arrays in any direction. Okay. So this is saying take every in elements, because in is how many marbles you do. So, okay, so now that you have your walks, okay, so it's taken the random walk, and now it's dropping the marbles. Okay, so this is where this is always interesting to me, because the way the problem is described is you are going on a random walk and you drop marbles. So in my mind, that means, okay, I take a step, then I take another step, then I drop a marble, then I take a step, then I take another step, then I drop a marble. This is slicing the problem a little bit differently, where it's saying, make the random walk, and then go back and drop the marbles, because that's a little bit more efficient. This is where we're kind of translating it from the way it's posed in our heads to the way the computer can do it most efficiently. I like that. So we're going to return dropping a marble at every n1, going from 1 all the way over. Cool. All right, what about convex hull? Now that is not a term I am familiar with. Let's go find convex hull. All right, so we make a stack. P0 equals min of PS. This will get relative to P0 the longest points for each angle sorted by angle. Okay, so this is helping you figure out what points are going to have the longest line. Okay, so this is probably some algorithm for doing this that I'm guessing they looked up or something. If you want to learn how to do it, go study that. That's all I need to know, is that it's getting you that farthest point there. That's kind of cool. So the technical term for that is a convex hull. That's good to know. And then you make the longest line out of that. That's pretty straightforward. That's going to do meeting marbles. Now, what does that do? Def between P, return P in L or CCW equals 0. Okay, so so that's probably is the marble on the line. Okay, that's cool. Okay, so I've lost my marbles. That's what that's doing. That's pretty cool. We return all this information because that's the information you now need in plot walk, which is kind of cool. All right, and then stat main is going to do something very similar, except now it's going to give us what all that information actually is, give us the average, standard deviation, etc. for everything. So I don't think we need to go over that too terribly much. Okay, so that's really neat how that ends up working. So if I do plot main, again, it's going to be generating those. So it's kind of neat to know how it's doing that, where it's creating the random walk and then dropping the marbles, and then it figures out that longest line. That's pretty neat. Okay, so there's the longest line there. Yeah, it's actually, I see this now. It's actually highlighting in red the marbles that the line met. Okay, so it is counting going through the center exactly. Yeah, because otherwise, I guess that makes sense, because otherwise you have to specify the radius of the marble, which is actually a cool way to extend this problem, would be taking into account the radius of the marble. So let me put down a note here. Can we extend to marbles of finite radius, right? Like close enough. I guess that's the Parker weirdly concrete problem. So it's not going to count this one because it doesn't quite go through the center. Okay, that's why there's so few of them, because it's got to go through the exact center. And so if the line starts on 1, you're going to get 1. Okay, here it only gets the 2, despite it, it only crosses the line the one time, and it happened to not have them. Oh, so that's actually interesting. This is a really neat example, because I think that crosses through that point, and so that would give you another one if the marbles were distributed differently. Okay, I see now why this is an interesting problem. This is actually really, really interesting. Okay, so none of those count. So that one actually has a 0. I wish you could combine both of these. Well, you can. I wish the code went ahead and combined both of these and gave me the average standard deviation stuff out here. So this is going to be just the 1. This is going to be just 1, 2. That one's got 1. That one's got 2. Okay, so that's really cool. Well, that's cool. I learned a lot doing this. I learned a little bit more about Python, learned a little bit more about math, and most importantly, I got a little bit of inspiration for making beautiful code. I think I'll do another video where we take this and maybe do a little bit of investigation with it.